Hello everyone, welcome back to the channel. Today we are going to dive with the next very popular your machine learning project, that is credit card fraud detection. Previously I have uploaded the Amazon sales data insights from the e-commerce domain. Today we are going to continue the machine learning series with the end-to-end machine learning project, that is credit card fraud detection. I have uploaded the like the videos on the your cross validation, your regression matrices, feature importance, and so many videos. Soon I will upload about the classification matrices in detail too. So today's our goal is also based on the classification too. Here, I would like to tell you what libraries we are going to use in this project, for what purpose, and what is the biggest challenge in this project too. So let me open my whiteboard first. It will give you the very clear understanding actually what we are going to do practically in this project. Okay. So if you are at a beginner level, this is a really useful information, because some students got confused when they are directly jump onto the practical part, especially when they are at a beginner level. So I wanted to give you the blueprint about it. So today we have the data set credit card fraud detection. I have downloaded the dataset from Kaggle. You can also download from there. This is the dataset, and your goal is to predict or classify whether the transaction, not only transaction, credit card transaction, whether the credit card transaction is fraud or not. Okay. And the challenge under this project is you are going to face and solve, that is, this is highly imbalanced. Even this is the most common problem in a real time, right? Imbalanced. So we will solve it using SMOTE method. Okay. And the next one is what steps you are going to perform on this. Number one, EDA. We will do it using pandas, NumPy, Matplotlib, and Seaborn. Okay. These two libraries used for data visualization. And these two libraries we use for data manipulation. Okay. So this is you are going to use. And the second step is you are going to prepare data for modeling. Okay. So here, if there is any missing value, you will handle them. Missing value handling, if it exists, okay, and duplicates and inconsistency, if there is, okay. The third is we will apply the model on this random forest, classifier, and XGBoost. Okay. And for evaluation, we are going to use confusion matrix, and OCROC. Okay, and we will also do the comparison too in between both your random forest and XGBoost, which one is good one for your model. Okay, now this is the just I wanted to let you know what steps we are going to follow. Okay, what libraries we are going to follow. Apart from this, for model building you will use these libraries: XGBoost classifier, random forest, and you this is from your SK learn. This is your machine learning library. Okay, we are going to use this one, and then we are going to use the confusion matrix classification report of ROC2. Okay, so I will show you this practically all. So this was the just overview of your project, and in this project all features are without name. This is from V1 to V28. This is just because of applied PCA. This information is confidential because of the this is the banking transactions. Okay, so this information is we can't show it, and the data set we you will ever download about it, you will find these features with these name. V1, V2, V3, this is just because of PCA, because PCA transformation is done on this data set before. Okay, for the security reasons. So now I will share my screen. Look at this. So here, first of all, I have written the your data dictionary. The time number of seconds elapsed between this transaction and first transaction. So the time given in this is in seconds per second the transactions. Okay. And the you have the V1 to V28 results of PCA transformation to protect confidentiality of your original features. Okay, maybe might be you think at a beginner level what is this, I don't understand what are these. And that's why I'm explaining you, this is just because this is for the it will happen after the PCA transformation. So whenever you will download the data set from the Kaggle or from any place, you will never find the original feature name. This always be like this to keep confidential the confidentiality of the original feature. And the amount is another feature given in this that is a transaction amount, and this is your target feature. And 0 belong to non-fraud, 1 belong to fraud. Okay, I'm using the Google Colab, so I have uploaded the data set here. If you don't know, you are totally at a beginner level, you don't know what is Google Colab, you can watch my video, that is what is the difference Google Colab versus Jupyter Notebook. Okay, and if you are using the Jupyter Notebook, you have to keep the data set at the same place. If you are placing it in a different folder, then you need to set a path here. Okay, so here, as I told you, we are going to use these 4 libraries. This is the mandatory libraries whenever you start your work in machine learning. Okay, this library I have imported to avoid the extra, like the sometime warnings come when you run the cells, right? It shows many, like the output, this is a warning, this is a warning. To avoid those things, you can import this library. Okay, then we will load the data set here. So this is, we are using the read underscore CSV file, and then we are creating the data frame. Look at this. First, we will explore the data set. Okay, now I am making the copy. Why? To avoid the data leakage, number 1. Number 2, so I can preserve the original data set copy. Because this is important. If you are going to collect the data from the many places, and you did a lot of spent a lot of time, and sometime what happened during the analysis or data manipulation, unfortunately, or sometime it happened, we do some changes which were not required, and we want to don't want to make those changes. So in that case, you should always have the backup. This is the good, like the wise decision, to keep the backup of your original data set. Okay, and then we are just exploring the data set. Look at this. This is the time column. This is coming in the seconds, and these are the all feature V1 to here you have V28, and this is the transaction amount, and this is your target feature, and it has a 2 categories: non-fraud or fraud. 0 1, 0 belong to non-fraud, 1 belong to fraud. Now we will check the all information about the data set. This is the info method, very popular method. This is used to explore your data set at a deeper level. It will tell you about the total number of the records. We have a good amount of the records actually. This is even it is only for 2 days. This is your 2,84,807 entries, and you have a 31 columns in this. Okay. And then look at this. This is the time all features are coming in the float. Only your last one is coming in the integer. And it doesn't seems to be any missing value here. All are complete. And you can see it is telling you column name, non-null account, and data type, and total number of records. So you can see using a small method of the pandas info, you can look at your data set in very detail, right? Because if you are using the head method, you are not able to understand clearly. If this is given, you might say, Nija, this is a float data, but you never know in which format it is. If you go back and check my Amazon sales data, insights, you will understand. All features are coming in the object, even the amount too. Okay, so that's why we use this method. This is important and basic for your data analysis. Check the balance of the data set. As I told you, this is a highly imbalanced data. Might be you are thinking, how would I come to know at initial level this is highly imbalanced? This is true. How would you come to know? So whenever you are working with the classification data, this is your duty to check if the data set is balanced or imbalanced. Do it at initial level. Even it is a balanced, there is a no harm, because this is just the one command you need to run and you will come to know. Because if it is going to be highly imbalanced, then your model can always be biased, because it will give you the during training, model will give the priority to the weightage to the classes which whose records are exist in your data set as a majority. So it will give the weightage to the majority of the class. Major class means. Now, if you look at this, 0 is the major class, 1 is a minor class, because 1 belong to, so this means in our data set, we have a 492 fraud transactions record. On the other side, we have a 28, 2,84,315 non-fraud transaction, right? So if I build my model using this imbalanced data, definitely my model will not be able to understand this one. And tomorrow, if I'm giving the new test data, it will work good on the training. But if I will give tomorrow with the 500 transaction, fraud transaction, then it might say, no, 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 this is not fraud, because model was not trained properly and your model did not get a chance to learn about the this class. Okay, so that's why this is very, very, very important to handle this. Okay, now we will move ahead with the checking the missing value using over this like the, sorry, not this is the one. I think I have typed it. This is this. Sorry about that. So first we will look at it graphically too. We are using here seaborne count plot. Here I am using the ed underscore df. This is a copy of the original data set. I'm not going to work with the original data set. Here this is the axis is equal to class. This is the target feature. Palette is the color. You can make it anyone, whatever you like. Okay. You can watch my Seaborn video. I have already uploaded under the data visualization playlist. Okay. If you are interested to get in this expert, the Seaborn, then you can watch that. Here we are doing the just calculating the percentage of the fraud detection, because here we are just looking at the numbers. If you are interested in the percentage, you can also do that. See, 99% your records belong to the non-fraud person, right? And the only 17% records you have with the fraud person, right? Or fraud detection, fraud transaction, not person, sorry. Here you can look at it graphically too. Look at this. So how big is the count? About 2,50,000, right? And one, it is not showing at all here, right? Because it's very small. Okay. And now we will start with checking the missing value. This is the basic method. We check is null dot sum. It will tell you if there is any null value exist, NaN, missing value. If we look at this, there is a no missing value. It's good to go. Now we will check for the duplicates. We are just exploring the data set here right now. I did not make any data manipulation here. These are the basic methods. Even in the interview, whenever you are getting this coding challenge, then you should follow these methods. Don't assume, never assume yourself like I don't need to check the duplicates. I don't need to check the missing value. This is the basic part, okay, process part. And then we will use the duplicated method dot sum. There are a 1081 duplicates value, okay. And now we will drop the duplicates. In place is equals to true means I am permanently making changes in my this data set or data frame, because this is a copy. I can manipulate it. If you are dropping the duplicates before the train test split, that is fine. There will be no data leakage. Okay. And then we will move ahead with checking the basic of the statistics. So what is that? This is the most popular method to check the statistics of your each feature. Although describe method, if we are mentioning like eda underscore df dot describe, I'm not passing any parameter inside this. What is that parameter? This is the one here. Include is equals to all. By default, it is include is equals to none. So if I am not mentioning this include is equals to all, then it will only show the statistics of your integer variable. And if you are interested to look the statistics for categorical too, you can say include is equals to all. But over today, our data set is contains only the integer variable, so we don't need to worry about it. So look at this, it is showing the total count of each feature, the mean value of each feature. Mean means average value of the each feature. Standard deviation, this is the like the standard deviation range of the data variation. Minimum value, what is the minimum time transaction? 0 second. And then there is a maximum seconds of the transaction, 172792. This is the elapsed time between each transaction, like the transactions. If we go back, that's why data dictionary is important. Time number of seconds elapsed between this transaction and the first transaction in the data set. Okay, from the first transaction to your how many transactions are done in a 1 day or 2 days. Okay, so this time is about that one. And now we will look at this, and this is the maximum range: 75 percentile, 50 percentile, 25 percentile, minimum. This is called interquartile range. Interquartile range, you need to go with my statistics series in detail. I have already explained it. Okay. But in short, this is calculated like how much 75% data belong to at what number, 50% of the your data of the feature, and 25%. Okay. And it is showing for all features. Look at this. It also gives you the idea about the outliers too. If your maximum value is very far away from the mean, so there might be outlier exist. Outlier means your data point is very far away from your mean value, average value. Okay. Now we will do the correlation heat map. This will help you to check the correlation of each feature with the target. This is very big, so I try to make it a bigger one. First I am considering the all features. We have a 28 columns in this, not 28. We have a, I think 31, including overtime. And that one, so how many columns we have? 31, right? And then we are just checking. Look at this. So although it has a 0-0 relationship, but somewhere you have like this amount. This is 34% positively correlated with your target one. Okay. And which feature is this? This is your V20. Okay. Now if you look at the amount, this is negatively correlated 23 with the V1. Okay. And with the time, how much it is correlated, and 40% V1 with the amount. Okay. And this is positively highly correlated. Okay. So it will show you the relationship between the features because this is the target. 17% it is connected with this one, and how much with the class? This is 40%. Okay. And now I have fetched out the actually top most important features now. How did I did that top correlation? I find the correlation based on the your target feature only. Okay, and then making it absolute. Absolute means positive value. Okay, we are just changing the magnitude of the value, and then sort the values. Ascending is equals to fall. The values will fall in the descending order. The highest value, lower value, and so on. And then you have a starting from the 1 to 11. So what is that? This is your column features value, index to dot to list. Okay, we are converting it into the list. And then we are plotting it. Look at this. This is much clearer than this. Okay, so now here we are just checking it, which is a highly correlated with this one. We are setting up the here your features value. You're from 1 to 11. Okay, and then look at this. Okay, so it is showing you only the features which is highly correlated with your target one. Okay, might be you are thinking, how would I decide these are the important features? I just took the here by looking at this here, right? And I want to explore some features from 1 to 11. If you want, you can increase it too. Okay, here you can make it like, let's say, up to 15. Okay, you can also do that. So it will show you the all top 15 features related to your class. Okay. Now look at this. It is showing about this. We need to make it a little bit bigger here. Let me increase the size. You can also do that. Okay. So it will increase the size of your this one. This look much better, right? So it is showing now from V2. Okay, and it is showing you very clear the all values. If you don't want to consider the all 28 features, because it doesn't seems to be all features are highly correlated with each other, right? And then here I did not consider the time and amount as well. Okay, I'm only considering from this to this one. Okay, so these are the top features. If you look at this, V17 is a negatively correlated with your target one, 31%. And then V14 feature is 29% negatively correlated with this one. Relationship either a positive or negative. If it is strong, this means this is related to your target feature. Okay, because there are a three type of relation: negative, positive, no relation. No relation, we don't have any use. Okay, it seems to be here you are only this one negatively high correlated V70. Okay, if you want to increase more, you can also increase more, let's say 18. Okay, so this is, I'm just showing you the different cases. If you want, you can pick up according to your requirement. Okay, and now it is increasing. It will pick up the now the most important your V19 here, V8 here, and it is sorting it based on the your relationship too with your target one. Okay, and if you are a beginner, you don't have a knowledge about the heat map, so this is your color bar. This is showing the highly positive correlation if it is a highly red, and then if lighter, less positive correlation, and if it is a negative high, the high purple color, this means a highly negative correlated with your target. Okay, zero means no relation. Okay, now we will move ahead. We will do the visualization distribution of top correlated features. So I am picking up it at a random basis. V18. This is negatively this one related. V17. Okay. And you can pick up, this is very small relation actually. Look at this. 0.044. We are interested something like this. 17%, 18%, 19. So you can pick up the, we are also drawing the visualization. Let's check how the amount is related with your the distribution of your like the with the corresponding to the target. We will make a list of these one, and then we are just here for call and import feature, and we are plotting all these graphs. Look at this, the first graph. Distribution of your V18 feature. If you go back and look at here, V18 feature, here we go. So this is negatively correlated 11% with your target. Now look at this. How it is like showing the distribution of there you were looking at the numbers, but we are not able to understand whether it is negatively correlated with the fraud one, which class belong to this one, right? So this graph is showing you distribution of V18 by class. So orange color belong to your fraud class, blue color belong to non-fraud class. So when your V18 value is between minus 2.5 to 2.5, your non-fraud like the your density is high. So between this range, your non-fraud transactions lie most of the time, most likelihood, right? And if we talk about the fraud transaction, this is between the your minus 10 to 5. This is the fraud transaction is happening between this range by this feature. We don't know the name of this feature, but this is the way how it is correlated, and it is telling us the relationship and at what time this is related with the fraud case or non-fraud case. Okay. On the x-axis, this is showing the values of V18, and this is on the density, the like the distribution of the data of the non-fraud cases or fraud cases on the y-axis. If you look at this, the V18, the fraud, your non-fraud cases is distribution is above 50% between this range of your the value of your V18. Okay, and the fraud cases, the value is between minus 2.5 to 2.5 maximum, and the distribution is between your maximum 0. You can say here between the value of this one 0.002 or something like that. Okay, this is the way how you will interpret this graph. Now the next graph, look at this V17. So now V17 values on the x-axis, and the density of this one is on the y-axis. So how many fraud cases are like V17 between what range? This is below your 0.1 distribution, less records, right? And non-fraud record is between only this one. Okay, 0.6 distribution, right? Values. And then here for the your V14 class, okay, this is showing here between the fraud and non-fraud this distribution. But if we look at this graph, this seems to be V18 is strongly correlated with fraud and non-fraud, right? It seems to be less correlated. This is also, it is little bit, this is also high, but the density is high here, right? Because this is a more wider. This is little bit sleek. Look at this. Okay. So it is giving you very good idea. And V12 is more fraud detections. See, not detection, fraud transactions. Okay. And here V10, look at this. This is between these values, right? And here amount has a very, like, let's say this is overlapping. So this means the amount between 0 to, we can consider it 1000 or maybe 1500 or 2000. The transaction is happening fraud or non-fraud. It's overlapping with the within the same range of the amount actually. Okay. Now we will check the distribution of amount, how the amount is distributed. This is the graph of that one. We are using here a histogram plot. And then look at this. That distribution of transaction history is between only 0 to 25,000, but maximum values is lie between your 0 to, let's say, 5 to 700, right? And its count is how many? It is very high. It is coming in the logarithmic form. So this is very high. So this means your mostly transaction is happening between this range 0 to 1000 or 1500. And there are a big transactions, this one, but this is less, very less. Okay, but the high count of the in our record, the data set, the higher transaction is within this amount. Okay, and now look at the this time. So what it is showing, this is showing the distribution of the transaction time, like in how many seconds each transaction is happening uh, most of the time. Look at this, this is at the peak, and this is your kernel density, this is the line. Okay, this is, we call it KDE, kernel density. Okay, the time, this is between the 0 second to this much seconds, and the highest time of the transaction which is happening at this second, because this is the highest point, right? And less transactions are happening between these seconds, and minimum is between these at these seconds. Okay, so this is the way how you can visualize the, like what we have done. We have done the correlation, we try to check that one, we have checked the distribution of the your data set contain how many of highest amount of transaction. We are just looking at the at what seconds most of the transactions are happening, and we have also checked the correlation with the target of the main your like the features which is highly correlated with your target one, and how they are distributed and connected with your fraud, to which class, fraud or not fraud, right? And now we are just doing the comparison between the fraud versus non-fraud. This is all is EDA actually. First we did the EDA using the numbers like info, missing value, duplicates. Now we are doing the EDA using visualization. And now look at this, we are using your box plot. This is the best graph even if you want to check the outliers. Definitely there are multiple outliers. Look at this. This is the class, right? And here this zero class belong to your what, non-fraud. This is fraud, right? So how many transactions are done with the fraud, because our goal is to reduce this one, right? So our model can predict correctly the fraud cases, so we can prevent them, we can remove them, we can block them, right? The cards, so the people will not be in trouble, right? So this is our goal. But here the amount which is a fraud transaction is happening maximum $4,000 if we look at this, right? This is the one. Rest 25,000. Okay, the amount, the like the transactions happening which is not fraud. Okay, so this is giving you the very like the good clear picture about the your amount based on the your fraud or not fraud transactions. Okay, this is very important graph. Okay, correlation analysis, we are just earlier I have showed you the heat map. You can also look at it based on the numbers too. So in this, we will help identify the features most strongly correlated with the fraud. So we will drop the fraud class from here and we will show the all features. Look at this, 14%. This is in the ascending, descending form. Then V11 is 14%. And if we look at it here, all rest are negatively correlated, right? These all are negatively correlated. V18 is, this is negatively correlated 105. That's why it was showing above in the graph with the fraud and not fraud highly correlated. Okay. Here, this graph is distribution of the time for fraudulent transaction. This graph is very, very important. Listen it carefully. This is telling us at what time most of the fraud transaction is happening. Like in a full day, people are the fraud transaction is are happening in early morning, mid of the day, afternoon, or what. So this is in the coming in the seconds. So if we look at this is the count. If you look at this, between 25,000 to 50,000 seconds, the highest fraud transaction is happening, right? How many? Above 30 fraud transactions. Okay, we are using a histoplot with the KDE. This is the kernel density. This is it is showing the average range, like the just setting up the line. and the second highest seems to be between at this second. Okay, if you want to do a more deep analysis, you can convert the seconds into hours. Okay, so you can also do that, but this is the most like the common, like the graph and the method we look at the distribution of the time for fraudulent transactions. This is very important graph. So till so far we are done with the your data visualization and your over a basic analysis, and there was the no missing value. Duplicate value we have dropped because duplicate is not going to harm your model. Okay, and now nothing is to handle. There is a no categorical feature. We are not worried about to transform the data. We are only worried about to scale the data. I'm going to use the first random forest classifier, and then we will jump on to the your XGBoost. Okay, and in this, like we are also going to use a rock today. This will give you the very clear picture how is your model was able to classify the fraud or non-fraud transactions properly or not. Okay, so look at this. First we will check this is the just we are checking the missing value, no, and then we will import the sklearn model selection train test split. This is the package from your Python sklearn machine learning package. You need to import model selection and then train test split method. This method is used to split your data set. Here we will drop the target feature, set the target feature so we can split it. We are going to use here stratify is equals to y. Stratify is equals to y means yes. Why we use this parameter? We use this parameter especially when your data set is imbalanced. The reason is we do this so whenever overtrained test split will split the data set, it should not like shift the all your non-fraud classes to like the in a X train only. It will divide the data at a equal level. If there are a let's say X train, X test, Y train, Y test. If I don't use this, might be your like the Y train contain only the fraud cases. Okay, or maybe only the non-fraud cases. This will happen. Okay, but if you use this stratify is equals to y, it will like divide the data set at a equal level. It must contain some value non-fraud or some value fraud. Okay, this is the reason we use it. So whenever you have a imbalanced data, you should use it. Okay, and then there is the imbalance_over_sampling imports SMOTE. SMOTE is a method we are going to generate the synthetic data. It will automatically generate it based on your given values, so we can balance it before applying the model. Okay, and then we will SMOTE.fit resample X train Y train. Just keep in your mind whenever you are using the SMOTE method, it only applicable on the train data. We never fit it on the test data. Otherwise, there will be the data leakage. Okay. And now our classes are balanced. Previously, it was only 17%. Now it is 50-50. Okay. Now we will import the column transformer. If you want to learn it, you need to watch my previous videos. Column transformer and pipeline. If you want to do mastery, this is we use to build the column transformer and pipeline to fasten our processing. So you don't need to write the code again and again. And then random forest standard scaler to scale your data for the your model preparation. The numerical one to make your all units at the sometime your data is in the different units, right? And then it will scale them at a all equal units. This is the reason. And these are the all matrices: classification report, confusion matrix, Rockock score, train test split, Rockock XGB classifier. I have done my all libraries imported. If you want, you can import these all libraries at the top level as well. But and then you can work it here. Okay. Now we will convert or separate out the numeric feature, converted it into the list, access your which we have used above to before the split of the data set. we will prepare the preprocessor. This is a column transformer, transformers, num, standard scalar, numeric features. What it will do, it will first select the features, scale it, and then prepare it for your model. Data prepare for model. Okay. Again, I will say, if you want to look at it like that detail, you want to learn it, you need to watch my column transformer and pipeline video. I have showed it graphically there. Okay. And then build pipeline. We will build the pipeline with the random forest classifier. Pipeline steps, which it will first preprocessor. What the preprocessor will do, I will tell you here. Now look at this. This is going to be your pipeline. Okay. The first step is preprocessor. Preprocessor, what it is doing? It will pick up your all num feature. Although we don't have any categorical, it will scale them. Okay. It will scale them and then it will fit onto the model. So these all three steps will be done under one roof. This is only the purpose. Okay. That's why we are doing this. And if you want to learn it at a deeper level, you need to watch my video. Here we are using the n underscore estimators 100. This means it is going to generate how many random, like the forest classifier, random forest trees. This is the count of like an estimator. It will iterate over 100 times. And random underscore state is equals to 42. Random pipeline we will fit onto the resample data. This is a SMOTE data. Don't try to fit it onto the X train, Y train actually, because we don't want to use the imbalanced one. We want to use the balanced one. So I'm using here SMOTE sample data. Okay. And then we will just predict using test data. Here you have might, if you are a totally beginner, then predict means you are predicting the values now with from the your actual values, right? If I tell you here, but if you have already done one or two projects first, so you understood what is Y predict, right? So when you split the data, you have the X test there, right? So the actual value was, let's say, 0, 1, 1, 0, right? So this is the like the values. I'm just assuming it can be any value. It can be 2.3. I'm just assuming the one feature actually. There are multiple features, right? We want to be 28. But when it will predict, this is the predicted by model. Okay. So based on these features, we can consider it here. Let's say other feature too. Let's make it. Okay. Let me draw it again. Okay. I'm just explaining it. If you are a totally beginner, this is the first time you are going to build this model. So let's say we have the feature V1 to V28, right? And this is your predicted. This is your actual value, right? X test. This one. It can be any value. Okay, I'm not writing value. It can be any value. What your model predicted, whether your model is saying he is non, this transaction is non-fraud, this transaction is fraud, this transaction is fraud. So this is called Y predict. Okay, this is called Y predict, predicted by your model. And now if you look at this proba, you might not heard about it. Proba, this value is going to give you the numbers, whether it will happen or not. Fraud, non-fraud, fraud. It is just the numbers, but it is not telling you what percentage of the chances these transaction can be fraud or non-fraud. That is called probability actually. Okay, that is called proba. So how would we do that? We will predict underscore proba. Instead of using only predict, we will say predict underscore proba. Sorry. And then X test. What is this? This is your all records from the X test. Okay. If you have a, what was the X test? We, by default, it is divided into 25%. So 25%, how many records are coming in the 25%? That of the data, and we are picking only the which case? Fraud case. Okay, one belong to fraud case. So it will tell us what are the chances of these transactions lie under the fraud cases. Might be the value of this one is, let's say, 95%. So this means your whatever your model is predicted belong to your these transaction will be 95% belong to fraud classes. These are the chances, like there are 95% of the transactions are fraud. This is going to tell you the percentage, but here it is telling you the number actually. This is only the difference. Now you are thinking why I'm calculating it, because I want to draw the raw cock. Okay, so it is a requirement for that one. Now look at the result. We are drawing the confusion matrix, y test, random predict. This is your predicted value, this one, and the y test. Okay, so we are plotting the like the comparison between actual and predicted one. Okay, so this is classification and this is a score of raw cock. I will show you it visually, but these are the numbers. Okay, this is your true positive, true negative, false positive, false negative. But I will make you understand at below. But we can see the raw cock value is 96%. This is very good for your model. Now look at the result here. This is graph. So confusion metric we will plot the simple way, and here we are calculating the first the value of the FPR TPR threshold. I will make you understand it now. What is that? FPR means false positive rate and TPR means your true positive rate. Okay, and threshold, at what value it is changing, I will show you in the graph what is that. And this is the rock underscore curve. This is the inbuilt method. I have imported it in the library. You don't need to create it. This is the inbuilt y test, and this is here we are using this parameter. Okay, and then rock of score, and then we are calculating this score here. Now look at this. First I will make you understand rock of. Here on the x-axis, this is false positive rate. False positive rate means your machine, your model is not able to predict the transaction was actually like you say non-fraud, and it is saying no, this is fraud. Okay, so this is called false positive rate. But here true positive rate means your machine was able to predict correctly this transaction is not fraud. Correctly, false positive rate, true positive rate. Okay, so here look at this. Now let me open my pen here. Listen it very carefully. This is very important graph. So this is the middle line actually, this one. Okay, if you on the x-axis, on the x-axis is false positive rate and this is a true positive rate. So in this, what is happening? Awk area under curve. The full form of awk is area under curve. This is the receiver operating your system. Okay. This is the receiver operating characteristics. Sorry. This is the area under curve. So how much area under this curve is covered? This one. Good is your model. In case your this blue line is not above this might be like this. Let's say this is like this blue line. Okay, and let me use the different color here. Okay, this one, this line might be like this or maybe like this. So when your this line is coming here, your model is not good. This is dumb model. This means your model did not learn anything and it is saying the wrong thing. False positive rate is too high. This means your actual transactions are not fraud and your machine is saying no, this is all fraud. This is that model. This means it is not reducing this. If there are a total, let's say 100 transactions total, right? Out of this, you have a 80 non-fraud and 20 fraud. Okay, and then what it will do? Out of 80, it is saying all 80 are fraud, false positive. This is the called false positive and dumb model under this. Let me clear this one all. Okay. So now it is saying its a true positive rate is high. This is our goal because we want to increase this, right? And we want to here decrease this, right? And we also want to increase this because we want to check if the transaction is fraud, my machine also should say, yes, this is fraud. We need to reduce this one, right? This one. And we need to increase this one. Right? Because if it is a fraud, my machine should also predict it's fraud. So that's why your true positive rate is very high and your area under curve value is 96% because it is starting from 0 to 100 and your threshold value is starting from here. Threshold value is calculated based on the this. I will show you. TPR minus FPR. Okay. And it is best threshold value. It is saying 0.050. So it must be around here. Okay, 0.050. So it is like going to change here, straight line, right? And this means your model was able to predict true positive rate 96% probability of to detect the your non-fraud transaction correctly 96% by your model. I'm repeating, if your model has the, let's say, this much total like including this one, right? These are the total transactions, so your model was able to predict 96% correctly transactions are not fraud. This is wrong, right? It is saying even the transaction are not fraud, your machine is saying they are fraud. We want to reduce this, right? And this is 96%, it was able to detect this one. This is the meaning of this awk. Higher the value of awk, best is the model. If it is below 50%, you have a dumb model. Because this is, you can say, because it is increasing the false positive rate. Because when the true positive rate will increase, when the true positive rate will increase, the line will also increase in this direction. Okay, and it will draw like this. But if this is increasing and this is decreasing, the line will not go here. It will like go something like that. This is dumb model. And when you have a straight line like this, you have the excellent model, right? Because it is 100%. Right now its accuracy is 96%. We can consider here, right? It's near if you consider this line. Okay, and these are the different threshold values. This one, when it is like going like changing the little bit direction like this curve. Okay, this is threshold and it is calculated automatically when you have this one here based on this. Okay, that's why we were giving the probability here. Okay, so it will check the probability of happening, the chances of true positive rate. Based on that, it will calculate the FPR, TPR, threshold, and then plot the graph. If you want to see the all threshold value, you can print it here. Okay, and then look at this. So when you are applying the random forest classifier, it was this much, but it was predicting wrong values, which are a non-fraud 9, right? But here, if you look at this, 22, it predicted not fraud, and 73 fraud, which is correct. We want to reduce this, increase this. Because if transaction is fraud, our machine should always say it's a fraud. If it is saying not fraud, then we will not be able to like uh, save over amount, right? Anybody, the fraud person will take out your all money. Okay, so that's why this is important. Now we will like move ahead with the next one. This is, I'm just showing the feature importance. This is after your model building. Actually, it is telling you during the model building, the model training, it is using the V14 most of the time, V14 feature, and then V10, V12, V4, and so on. This is very useful information. You will come to know which feature it is using. Although we don't know what is V14, right? But if you are applying this method to other your data, this is very good. It will tell you which feature your model was using most of the time and which is not using too much, then you can drop them. Look at this, V18 is used less time. Although in the upper correlation, it was showing high correlated, right? And then look at this. How did we do that? We are just mention the classifier and we are picking a feature importance. This is inbuilt. Okay, you don't need to do anything. And then it is just printing the score based on the score. It is printing the result. Okay. And now we will apply the XGBoost on this. XGBoost classifier. Here we are using this label encoder evaluation metric. We are using here log loss. Okay. Yeah, this is evaluation metric we are using here. And then random state. Here we are applying these models and confusion metric. This is same. Nothing is changed. Only the model name is changed. And then look at this result. This is also showing 96%. So this means there is a no too big change, right? We have applied two models, random forest classifier, XGBoost classifier. So now look at this. Here is a change. We are able to increase this count actually. Okay. And I will show you, I have drawn the like a graph below for the comparison. Okay. But you can take an idea from here. There is a no big change. Okay. But I will show you here in the graph. First, I am just wanted to show you the random forest versus XGBoost model. Which model have used which feature most of the time according to the feature importance score. Okay. So this is, we are using the same named step classifier feature importance for your random forest and for your XG classifier. And then we are just plotting the graph. Look at this. V14 feature is used 70% above, like around 70% by XGBoost. And this is also used by your random forest and so on. This is also very useful information. It is giving you very good information and you know now which feature you can keep. You can like drop some feature and you can fit the model again and try if it increase more than 96%, right? Now this is a comparison. This is, you should look at it carefully. Look at this. So here it was able to predict correctly your the fraud, non-fraud cases, right? 56642. Here it is decreased in XGBoost case, right? And this is increased. Definitely, if it is decreased, it will increase. False positive, right? And here it is saying this is fraud, this is increased, right? And here, sorry, this is decreased, sorry, this is increased. This is good news for us because this is our goal too, right? Our goal in this kind of the data set, our goal is to reduce the false positive, right? And increase the your, which one? This one. This is true positive, true negative, right? Because if the your transaction is fraud, your machine should also predict it correctly. It is fraud. Otherwise, it will be the huge loss for any customer, right? Even this you can consider not as a comparison to the fraud one, we can consider it less dangerous because if it, even the transaction is not fraud, we are just sending them the emails from the bank. This is a fraud transaction, but there is a no loss. The customer will just call you back, right, one time and they will confirm, that's it. But in case If this is wrong, there might be the big loss. We can't afford it. Okay, so this is our goal, to increase this, reduce this. So XGBoost is doing good in this case. Rest you can delete the features as you have seen, right? And then fit the model again. But this is all about our today's credit card fraud detection. And I have shown you like how you can check the feature importance too, which feature was used most of the time by the model, and draw your curve. Definitely, I will upload the separate video too about your confusion matrix and Rockock. Okay, and you can watch that too to understand it at a deeper level. Because here I have made you understand according to the over project. Okay, and this is all about our today's like the discussion, credit card fraud detection. If you have any question, feel free to ask me. Definitely I will share the notebook too. And keep working, keep learning. Happy AI coding. See you in the next session.